Hi, I'm Torben Jansen from thoughtsonjava.org. Today I will show you how to map blobs and clops with JPA and Hibernate. You will learn how to map these database columns to a string or a byte array, and how to use the Java SQL classes blob and clop. And at the end of this video, I will show you an easy and portable way to load your blobs and clops lazily. Especially the lazy loading trick is a mapping that most developers are surprised about and that I have used with great success in various client projects. But before we start, if this is your first time here and you want to learn how to create your entity mappings with ease, build incredible efficient persistence layers with Hibernate, and all types of other Java persistence related stuff, start now by subscribing and clicking the bell so you don't miss anything. Okay, let's dive into today's topic. Databases use the data types binary large object, aka blob, and character large object, aka clop, to store large objects like images and very long texts. JPA and Hibernate provide two kinds of mappings for these types. You can choose if you want to materialize the lob and map it to a byte array or a string. This mapping is defined by the JPA specification and prioritizes ease of use over performance. Or you can use JDBC's lob locators Java SQL blob and Java SQL clop. The lob locators enable your JDBC driver to optimize for performance, for example by streaming the data. This mapping is Hibernate specific. The mapping of both approaches looks almost identical. You just need to annotate your entity attribute with a lob annotation. The only difference is the type of your entity attribute, but you will see a huge difference in the way you use the values of these entity attributes. Let's use both options to map the following book table. The columns cover of type OID and content of type text are the important ones for this video. We will map the cover column to a blob and the content column as a clop. The materialized mapping to a string or a byte array is the most intuitive mapping for most Java developers. Entity attributes of these types are easy to use, and it feels natural to use them in your domain model. But Hibernate also needs to fetch all data stored in the lob immediately and map it to a Java object. Depending on the size of your lob, this can cause severe performance problems. If you, for example, store large video files in your database, it's often better to use JDBC's lob locators. I show you how to use them in the next section. The JPA specification defines this mapping. You can not only use it with Hibernate, but also with Eclipse Link and OpenJPA. Creating materialized mappings is very simple. You just need an attribute of type string or byte array and annotate it with JPA's lob annotation. Hibernate can also map naturalized character data types like nchar, nvarchar, long nvarchar, and nclop. To define such a mapping, you need to annotate your entity attribute of type string with Hibernate's naturalized annotation instead of lob. As I said at the beginning of this video, materialized mappings are straightforward to use. Hibernate fetches all data stored in the lob when it initializes the entity and maps it to a string or a byte array. You can then use the entity attribute in the same way as any other attribute. Here are two examples that store a new book entity and fetch an existing book entity from the database. With Hibernate, you can use the same approach to map your lob to a Java SQL clop or Java SQL blob. These Java types are not as easy to use as a string or a byte array, but they enable your JDBC driver to use lob-specific optimizations, which might improve the performance of your application. If and what kind of optimizations are used depends on the JDBC driver and your database. The mapping is Hibernate specific and not defined by the JPA specification. As you can see in the following code snippet, the mapping of JDBC's lob locators Java SQL clop and Java SQL blob is almost identical to the previous example. The only two differences are the cover attribute is now of type blob, and the content attribute is of type clop. And Hibernate also enables you to map the nationalized character data types nchar, nvarchar, long nvarchar, and nclop to a Java SQL clop. The types Java SQL clop and Java SQL blob provide more flexibility to the JDBC driver, but they are not as easy to use as a byte array or a string. You need to use Hibernate's blob proxy and clop proxy classes to create a blob or a clop. As you can see in the code, that's a rather small inconvenience. To create a blob object, you can call the generateProxy method of the blob proxy with a byte array or an input stream. And you can call the generateProxy method of the clop proxy with a string or a reader. That makes both proxies very comfortable to use. Reading a blob or a clop is also not too complicated, but requires a little more work than using a byte array or a string. The Java SQL blob interface provides you with multiple methods to get an input stream or a byte array of the blob value. And the Java SQL clop interface defines various ways to get a reader or a string of the clop value. When we are talking about lobs, we also need to talk about lazy loading. In most cases, lobs require too much memory to fetch them eagerly every time you fetch the entity. It would be better to only fetch the lob if you need it in your business code. As I explained in a previous video, JPA defines lazy fetching for basic attributes as a hint. That means that your persistence provider can decide if it follows that hint or fetches the value eagerly. As a result, the support and implementation of this feature depend on your JPA implementation. Hibernate, for example, requires you to activate bytecode enhancement. I explained that in more details in my Hibernate Performance Tuning online training. In this video, I want to show and recommend a different approach. It doesn't require any provider-specific features and works with all JPA implementations. The easiest and best way to load lobs lazily is to store them in a separate table. You can then map the lobs to a separate entity. That allows you to remove the lobs from the book entity and to model a unidirectional one-to-one association with a shared primary key on the book lobs entity. The mapping of the two entities is pretty simple. After removing the two lobs, the book entity is a simple entity with a generated primary key and a title attribute. As I will show you in the next section, you don't need to model the association to the book lob entity. The book lob entity models a unidirectional one-to-one association to the book entity. The maps ID annotation tells Hibernate to use the primary key value of the associated book. I explained that in more details in my Hibernate tip how to share the primary key in a one-to-one association. And the materialized mappings of the content and cover attributes are the same as I used in the first example. The shared primary key and the unidirectional one-to-one associations make using the two entities very easy. To store a new book in your database, you need to instantiate and persist the book and book lobs entity. The book lobs entity uses the primary key value of the associated book entity, so you need to make sure to initialize the association before you persist the book lobs entity. And when you want to get the book lobs entity for a given book entity, you just need to call the find method on your entity manager with the ID of the book. As you have seen, JPA provides an easy way to map lobs to entity attributes of type byte array and string. This mapping is not only easy to define, but it's also very comfortable to use and feels natural to most Java developers. The only downside of it is that it prevents your JDBC driver from using lob-specific optimizations. Hibernate takes the mapping of lobs one step further. In addition to the JPA mappings, it also allows you to map lobs to JDBC's clop and lob locators. These mappings are a little bit harder to use, but they enable your JDBC driver to implement lob-specific implementations like the streaming of large objects. That can provide better performance if you're using a lot of or very huge lobs. Okay, that's it for today. If you want to learn more about Hibernate, you should join the free Thoughts on Java library. It gives you free access to a lot of member-only content, like a cheat sheet for this video and an ebook about using native queries with JPA and Hibernate. I'll add the link to it to the video description below. And if you liked today's video, please give it a thumbs up and subscribe below. Bye!